Okay, guys. So, good morning, guys. Sir Sterling here. So we're going to start out with Unit 8, Day 1. Um, we're literally almost done with the entire school year. We have Unit 8 to complete, and then we have Unit 9 to complete. But of course, Unit 9 is going to kind of be a breeze for you guys because obviously we started out with that unit, if you remember, back in September with the energy pyramids and ecology and all of that kind of stuff. But we have to get through evolution. So, as we're going through this unit, a few things that you want to take note of is that this and ecology, so this unit and next unit, are the two most important units. Okay, so just make sure that um, you are aware of that. Um, and yeah. So, hopefully this video is working out fine. So, make sure that you have out Unit 8, Day 1, as that's going to be the worksheet that we're going to be going over. So, evolution. So, the aim for the day says, how does natural selection lead to the evolution of a new species? All right. And then the first question for the do now says, what is evolution? So I'm sure that you guys have heard of this word before. And evolution equals change over time. That's literally what it equals, a change over time. So what can that look like? You probably have seen like early man or like early humans and things like that. They never used to look the way that we do. They looked that way back then because their environment selected for them to look that way. But over time, as the environment changed, humans also had to change for the betterment of the species, right? So things like early man or like hundreds of thousands of years ago, like the first humans on Earth, they had a lot of fur and or hair on their body. And one of the reasons why we don't have a lot of hair on our bodies now, some of us, um, is because we don't need it, right? We wear clothes, we have like coats and things like that to keep us warm. And we know that the function of hair on our body is literally to keep us warm, to insulate heat. But over time, with global warming and those type of things, we don't need that much fur. So therefore, our body does not want to spend the energy for that. Okay, so evolution is simply a change over time to evolve and to acquire those traits that we deem to have the species survive um, as a whole species. All right, and then number two says, what causes evolution? So, one of the things that we just mentioned was the environment, right? Another thing that might cause evolution, which we briefly touched on in the last unit in genetics, are mutations, right? So the environment would cause uh, a change in organisms over time, right? So if you remember in class, like one of the things that we spoke about was people that live near the equator, they tend to have a darker complexion. And the reason why they have a darker complexion is because darker complected people have a lot more melanin in their skin. And one of the functions of melanin is the more melanin that you have, the more sunlight that can be absorbed through the skin, right? So that way it reduces your risk of skin cancer and things like that. So evolutionarily speaking, it would bode those humans well to have darker complected skin because they're constantly exposed to the sun's rays. Whereas if you live in the mountains of Greenland or Scandinavia or somewhere, on top of Mount Everest, you wouldn't need really dark skin because it's almost always cold and it lacks like a lot of sunlight and a lot of like those areas are full of snow, and we know that snow is white. So those people might not have much melanin in their skin because they simply don't need it. That's how the environment can kind of change over time that would allow, and then also what I said about like humans and like the amount of hair that they have, those type of things as well. Also our tailbone, right? Like, so we used to have tails, and one of the reasons why we probably don't have tails anymore is because we don't need them. We just don't need tails because we don't live, we live on terrestrial land, yes, but we live in apartments, and we're not swinging from trees in our apartments and in our houses and things like that, right? Like we don't live in trees, so we don't need that type of thing. All right. And then mutations, right? So mutations are extremely important to evolution, right? They're considered the raw materials of evolution, which was one of the questions on the test. Simply because mutations provide genetic variation. Genetic variation, right? So the higher the genetic variation within the species, the higher chance of survival. So this increases chances of survival. That's going to be an important concept. Please put a star next to that. Increases the chances of survival. Okay. All right. Now, number 3. I'm looking at the document on my phone. I don't know if you can see there. Um, Trust me, I'm not texting or anything like that. And neither should you. All right. And then number 3, what is natural selection? So if we just kind of break down the word natural, right? Ah, natural deals with nature, right? Things that are of the earth, right? So this has to do with nature. And then selection, right? A selection is what is chosen, is chosen over something else, right? So for instance, so really and truly, it literally means that the environment is what's choosing what's going to be passed on. The environment chooses the genes to be passed on. That's what's doing the selecting. So the environment selects. Okay. So the environment is going to be doing that. All right. That's called natural selection. Okay. And there's a few more things that you guys should like kind of know, like in terms of that, right? So oftentimes, like in science, evolution and natural selection are both interchanged in that. The theory of so natural selection, let me write it down. Natural selection drives evolution. So what do we mean by that? Natural selection drives evolution. Well, natural selection is the mechanism to which evolution adheres, excuse me, right? So for instance, uh let's actually just use the example that's on the sheet, right? So you guys see that there's a population of mice that moves into a new area where the rocks are very dark. Due to natural selection, or due to natural genetic variation, some mice are black, while others are tan. So as you can see there, we have black mice and we have tan mice. Okay. some mice are obviously going to be eaten by the birds. So the tan mice are more visible to the predatory birds, right, than the black mice. Thus, tan mice are eaten at a higher frequency than the black mice. Only the surviving mice reach reproductive age and leave offspring. Okay? So, because the tan mice have a tan color against the black soil, um, they stick out more. And if they stick out more, it's easier for the hawk or whatever the bird is to eat those mice. Obviously, if they get eaten, they cannot survive and they cannot reproduce to pass on those tan genes. So the ones that are going to survive and reproduce and pass on the genes are the black mice, right? So because the black mice had a higher chance of leaving offspring than tan mice, the next generation contains a higher fraction of black mice than the previous generation. Okay? So over time, right? Evolution is a change over time. Over time, the black mice are going to dominate essentially, and eventually the species is going to be almost exclusively black mice, but because of genetic variation it'll never 100% be black mice. Does that make sense? Now if some type of environmental change um was caused where they were no longer living in the soil, the black soil, and instead like the black soil was just like changed to tan sand, right? Like sand on a beach, the tan mice now have the upper advantage because they'd be able to blend in much better than a black mouse would. And so therefore the black mice would get eaten at a higher rate and the tan mice would be able to pass on those genes. And so over time, it would go from black to more tan to more tan to more tan until some type of environmental change comes and changes that again. Hoping that that makes sense. Um, okay. So part A, introduction. Applying Darwin's ideas. Read the passage below, then answer the questions that follow. Obviously, like as I'm reading, you guys are going to be annotating. The theory of evolution, a change over time, by natural selection can be summarized as follows. One, every population produces more offspring than can survive in an environment with limited resources known as overpopulation. All right, so overpopulation equals more offspring and fewer resources. What do we mean by resources? Food, space, those type of things, right? So in any population, or in any species, there's always going to be more offspring than can actually survive and reproduce, right? So if I have, if if I'm a bird and I eat worms, right? And there's like 6 birds that are competing, right? But there's only 2 worms. The 2 birds that are able to eat those 2 worms, there's a higher chance of them actually surviving and the other 4 will die off. Because obviously, if they're not getting nutrition, they're not getting a food resource, they cannot survive, right? So that's what overpopulation is. There's a ton of, you know, rabbits, but there's only one carrot. So the rabbits are all gonna flock to that one carrot in an attempt to like try and get it so that way they can like be nourished and be able to be strong enough to survive and reproduce and pass on their genes throughout the species. But most of those rabbits are gonna die because they don't have any food. It's that type of thing. Okay. Okay. And then the second one is all populations show variation in traits and much of this variation is inherited. That's pretty self-explanatory. Obviously, as humans, we don't all look the same, even though we all belong to the same population or the same species, right? Some of us are more prone to things like breast cancer, some of us more prone to sickle cell, and that's all based on the genes that we acquired from our lineage, from our parents, from our grandparents, that type of thing. In a given environment, individuals with traits that make them better suited to survive long enough to reproduce leave more offspring than individuals without those traits, right? So again, uh, if like the tan mouse versus the black mouse type of thing. If I live in an environment that's constantly dark, it would be much more of an advantage for me to have darker fur than for me to have tan fur because I wouldn't stand out as much to predators that are trying to basically eat, the tan mice. Um, or just hungry to like eat, right? Like we wouldn't stand out as much. So I would want to have black fur so that way I can blend in. If I'm able to survive to reproductive age, then I would be able to pass those genes on so to continue the species that are there. That's called better suited for your environment, right? That's called survival of the fittest. They're better adapted. All right. And then number 4, over time, inherited traits that improve the chances of survival and reproduction, called adaptations, that's in bold, so that's important, become more common than other traits within a population. In other words, the population evolves. Natural selection is also commonly referred to as survival of the fittest. So natural selection, NS, equals survival of the fittest. By fittest, we're not talking about right? Because, you know, we could be talking about that, but usually when people think of fit, they think of like, oh, somebody's very toned, they're very muscular, that type of thing. And it could mean that, but it doesn't necessarily mean that. Fittest, we're just talking about the genes that allow them to survive and reproduce. Genes that allow survival and whoops. Why is it doing this? What just happened? And reproduction. Sorry guys that this is like so sloppy, but survive and reproduce are two terms that we're gonna constantly be saying. So please get used to saying that. Survive and reproduce. That's the whole point of natural selection. We're able to survive until reproductive age, where we will then reproduce and pass those genes on. Then those offspring will grow and survive to reproductive age and then pass those genes on and circle and circle and circle and circle. And until something comes and interrupts that cycle, that's what's going to keep happening. Okay. All right. So it says, read each question and write your answer in the space provided. What does the word overpopulation refer to in the third line? So we discussed overpopulation earlier. Overpopulation, there's more offspring than can actually survive in any given species due to limited resources. Okay, define the word adaptations. So adaptations are traits that allow um, survival and reproduction of the species. How does natural selection lead to the evolution of a population? So remember earlier we said natural selection is the driving force behind evolution, right? So natural selection essentially drives evolution, right? It's the driving mechanism. It's the reason why evolution is able to occur. Okay. And why can natural selection also be called survival of the fittest, right? Because we're passing on traits that allow the species to survive and reproduce over time. Okay. Um, So you guys probably know that there are tons of animals like snakes that eat frogs. If you've ever heard of like the poison dart frog, right? Like it's this very, very, very toxic and poisonous animal. And what ends up happening is that over time it's built up a way of actually releasing toxins through its skin, through the pores of its skin. So if a snake comes and tries to eat it, right? Because snakes eat their prey whole, what do you guys think would happen, right? Those toxins would be released and the snake essentially would die and the frog would be able to crawl out of the snake's mouth, right? So because it's able to survive, it can now pass that poison trait on to the next generation so that way they can survive and reproduce. Now, if for some reason the snake was able to build up an immunity to that toxin, then those frogs, we would see a decline in that population because the snakes are no longer damaged or killed by the toxic substances that are pouring out from the frog's pores, so to speak, right? So therefore, the frog over time that has a more potent part of it, they would be able to like now pass on the more potent um, of the poison darts. Okay. This will make a lot more sense if it's not making sense now, but just keep in mind survival and reproduction, survive and reproduce. Okay? All right, now part B. So, read the following situations below and identify 5 points of Darwin's natural selection. Okay? So there are two types of worms. Worms that eat at night, nocturnal, and worms that eat during the day, diurnal. All right. The birds eat during the day and seem to be eating only the diurnal worms. The nocturnal worms are in their burrows during this time. Each spring, when the worms reproduce, they have about 500 babies, but only 100 of these 500 ever become old enough to reproduce, right? So that is the term of overpopulation right there, right? They had 500, but only 100 reach reproductive age. Same thing with fish, guys. I don't know if you guys have ever seen like fish, but a lot of times they release hundreds and hundreds and hundreds of eggs at a time. And some of those eggs don't even get fertilized. So that already like they can't become offspring if they're not fertilized, right? And then some of them will be eaten by predators and things of that nature. So if 100 eggs are released, maybe only 20 actually survive to reproductive age. That's the term overpopulation. You're producing a lot more, right? So Darwin's 5 points. Identify the 5 points in the scenario above. So the population has variations. So what were the two variations here? There was nocturnal worms and there was diurnal worms. Nocturnal worms come out at night, diurnal come out during the day. Some variations are favorable, right? So here, right, the birds that eat during the day are only going to eat the diurnal worms because they eat during the day. So therefore they're seen by their predator, whereas the nocturnal worms are not. So the favorable trait here are the nocturnal worms or the nocturnal trait, right? Because then they're going to be able to survive and reproduce because they're not being eaten. More offspring are produced than can survive, yes or no? Obviously, yes. We said that there was 500 that were produced, but only 100 that survived. And then those that survive have favorable traits. Yes, they have favorable traits because they were able to survive and reproduce. And then a population will change over time. Yes, the population will become more nocturnal over time because they realize this is a favorable trait. This is what needs to be passed on in order for the greater good of the species. Now, going back to letter A, which I totally skipped over, my bad. What worm has natural selected against? So which one is not natural selection not in favor of? So it's not in favor of the diurnal worms because those are the ones that are getting eaten naturally, right? Which one has it selected for? Which one is it in favor for? And that's the nocturnal worms that are there. Simple, right? Another one of Darwin's 5 points. So, second scenario, there are three types of polar bears: ones with thick coats, ones with medium coats, and ones with thin coats. It is fall and soon to be winter. The temperatures are dropping rapidly, and the bears must be kept warm or they will freeze to death. Many of the bears had approximately 2 cubs each, but due to extreme temperatures, many mothers only have 1 cub left, right? So even though they had 2 cubs, usually only one survived. Overpopulation, right? You produced more than can actually survive based on the resources or the conditions of the environment, right? So, what bear will natural selection select against? Well, if the temperatures are dropping, that means that it's becoming colder. If it's becoming colder, do you guys think that we need a thicker coat or a thinner coat? If you said thicker coat, then obviously you're right. So that means that natural selection would select against the cubs or the bears that have thinner coats because it doesn't do them any good to have thinner coats, and therefore they're more prone to death, right? Freezing to death. And obviously, natural selection selected for ones with thicker coats because the thicker coat ones, they're actually able to insulate, right? Remember the function of lipids, insulation and warmth, right? So they're able to insulate and hold on to that heat during really, really cold times. Darwin's 5 points in the scenario. Does the population have variations? Yes, there's 3 variations, right? There's thick coats, medium coats, and thin coats. Some variations are favorable. Yes, the ones with thicker coats are more favorable, and maybe some with like those thick medium coats are more favorable, but definitely uh yes, those are the favorable one. More offspring are produced than can survive, yes or no? Absolutely, yes, right? Um, the, again, they all had 2 cubs, but most of them by the end of the winter, they only had one that survived. So two, but only one survived. Those that survive have favorable traits. Absolutely. Where the thicker ones are able to survive and reproduce, which they are able to survive and reproduce, then that increases the probability of the majority of the cubs that are being had will have thick coats because it's more favorable. That's what the environment is selecting for, natural selection. All right. And will the population change over time? Yes, it'll change over time. They will end up having more thicker coats. Okay. Part C. Which characteristic is necessary for natural selection to occur in a species? So it says uh, stability, variation, complex cellular organization, or a very low mutation rate. So we know that the answer can't be D because, like we said, mutations actually help be one of the driving forces of evolution to occur. So if we have a very low mutation rate, then that usually means that the species is more similar than different, which is not always a good thing, right? Remember we spoke about asexual reproduction. If a virus comes like the COVID-19 or something like that, it'll wipe out everything, right? So more variations would actually be necessary for natural selection. We know that the answer can't be A, stability, because if everything was stable and the environment was stable, then nothing would really need to change, right? Natural selection is going to work on the environment in a changing environment, right? Um, the correct answer here is B, variation, which is what we've been talking about. Variations lead to different adaptations. The adaptations are able to help the species survive and reproduce. So we need much more variation. Okay. And then number 2, the diagram below represents the same field of mice hunted by a hawk over a period of 3 months. So this is very similar to what the picture in the do now question, right? The overall changes in the population of mice can be best explained by, okay, is it natural selection, succession, reproduction, or mouse extinction? So we know it's not D because the mice are not extinct. We are clearly seeing mice on the paper, and extinction means that there's absolutely no more of that population left, no more offspring of that population left. Um, Not succession, that's another term that we're gonna learn next unit. Uh, Not reproduction either, because the mice are not necessarily like reproducing obscenely. The correct answer would be natural selection. We see less white mice, probably because they weren't able to blend in. Obviously, the hawk is going to be able to see that, oh, like, I'm able to see the white mice, so that's what I'm going to eat, right? And then, as you can see from month 1 to month 3, there's obviously more black mice than there are white mice that are there. Now, if you look closely in month 3, you'll see that there's a white mouse that is there. That's due to variation. So remember when I said earlier, it's never going to be 100% this entire population is going to have the favorable trait. There's always going to be genetic variation. And so some of them, no matter what, will just have the white um, fur as opposed to the black fur that's there. Okay, so I was trying to get the PowerPoint and everything like that together. Hopefully by the next video, I'll be able to do that. Guys, thank you so much for everything. And I hope that you are understanding this. Please make sure you are doing your worksheets on time. If you have any questions, you can write myself, Miss Ivory, or Miss Collins, or Miss Parsons via um, Google Classroom, and we'd be happy to answer them or remind whatever might be easier for you. Okay, so tomorrow we'll be doing day 2. All right, so thanks for everything and have a great day.